Hello, this is section 5.2, the natural logarithmic function for integration. So theorem 5.5, log rule for the integration. So when we have u be a differentiable function of x, so integral 1 over x dx is same as ln x with absolute value, because we need to make sure x is always a positive number. And then for the integral 1 over u, du equal to ln u plus c, make sure u is always positive too. So alternative form of the log rule. So if you have an integral u prime over u, du is ln u plus c. Alright, let's do the example. So number 1. So I have an integral 10 over x dx. So I have same as 10 integral 1 over x dx. So now 10 and the integral 1 over x same as ln absolute value of x plus c. For the second one, I think I want to use a substitution. Let's say u is 3x plus 2, which is a du is a 3x dx, which means I can write this one as dx. I can put u over 3x. Sorry. What am I doing here? So 3 dx. So 3, and then I can pull the 1/3 out, integral 1 over u du, which is same as 1/3 ln absolute value u plus c, which is same as 1/3. Then u is 3x plus 2 plus c. Okay, alright, that's all. Next problem. So next problem, I want to say u is 3 minus x cubed, which is a du is negative 3x squared dx. So integral x squared u instead of dx, I put the du over negative 3x squared. And then x squared cancels out, pull out negative 3. Integral 1 over u du, which is the same as negative 1/3. And then ln u plus c. Then negative 1/3 ln u, and the u is same as the 3 minus x cubed plus c. Now number 4, I want to say u is 9 minus x squared, which is the u is negative 2x dx. So integral x over radical u, and then dx is same as the du over negative 2x. And the x cancels out, negative 1/2 comes out, integral 1 over radical u du, and negative 1/2, well, that's the same as u to the negative half du. And then I put the u negative 2, 1 over 2 plus 1, and negative 1/2 plus 1 plus c, which is the same as negative 1/2 of u to the half power over 1/2, which is 1/2 cancel, plus c, and then I got negative u to the half plus c, which is negative u is now 9 minus x squared, half power plus c, which is the same as negative 9, square root of 9 minus x squared plus c. Well, where did the 9 come from? Sorry about that. All right. And then the next one, I want to say u is, this time instead of the u first, okay. This is a improper the expression, rational expression. So I want to use a long division to divide it. So x cubed plus 0x squared minus 6x minus 20 and x plus 5. So if you use a long division, so x squared, x cubed plus 5x squared, and then I got negative 5x squared minus 6x, negative 5x squared minus 25x. I got 19x, drop the negative 20, and plus 19, I got 19x, and plus 95 becomes negative 115. So this problem same as x squared plus 19 and plus of negative 115 over x plus 5 dx. Now I'm gonna put out the integral individually. So x cubed 3 minus 5x squared over 2, 19x and minus 115. And then it becomes u is x plus 5. It becomes ln of x plus 5 and plus c. Okay, that's all. All right, for the next one. All right, the next one. Okay, it takes a little while, but you know, we're still gonna end it up the answers. Okay, so first of all, I want to multiply numerator, so x squared minus 2x over x, but denominator I don't want to. Okay, and then I want a little bit manipulate on the numerator because I want to make it move the square. Okay, so x squared minus 2x, adding the 1 and subtract 1 over x minus 1 cubed dx. And then for three terms on the numerator becomes x minus 1 squared minus 1 over x minus 1 cubed. And then I want to split the two rational expression as x minus 1 squared over x minus 1 cubed minus 1 over x minus 1 cubed. Okay, and dx of each. Integral dx. And then that cancels out as integral 1 over x minus 1 dx minus. And I have 1 over x minus 1 cubed dx. And then the first integral becomes ln x minus 1 and minus. Now I want to do this integration by itself, okay? So pull out here. So integral 1 over x minus 1 cubed dx. So what I want to do is I want to say u is x minus 1. So du is dx. So I can put out as 1 over u cubed du. Same as u to the negative third du. Which is same as u to the negative 2 over negative 2. And plus c. And then same as negative 1 over 2 u squared plus c. And then u was x minus 1 squared plus c. Then I'm going to replace back. Okay, so about negative 1 over 2 of x minus 1 squared plus c. And then eventually 1 over 2 of x minus 1 squared plus c. So that's all. All right, integral for the sixth trigonometry function. So integral sine u du equal to negative cosine u plus c. Integral cosine u du is equal to sine u plus c. And integral tangent u du is negative ln cosine u absolute value plus c. And integral cotangent u du equal to ln absolute value sine u plus c. Integral secant u du equal to ln absolute value secant u plus tangent u plus c. And the integral secant u plus secant u du equal to negative ln cosecant u du equal to negative ln cosecant u plus cotangent u absolute value plus c. All right, so let's try this. So the first problem, I want to say this time u is 5 theta, which is a du is 5 d theta. So I have an integral tangent u is du over 5. And then 5 integral and tangent u or 1 over tangent u du. And then integral tangent u same as negative ln of cosine u plus c. And then negative 1/5 of ln cosine u plus c. And then u is the same as 5 theta. So cosine 5 theta plus c. All right, for the second one, I want to say that the u is cotangent t, which is the du is the same as negative cosecant squared t dt. So integral cosecant squared t over u times du over negative cosecant squared t dt. Yes, squared t. Alright, cosecant squared t cancels out. I got negative. And the integral u, which is same as negative. And then ln u is the same as cotangent t plus c. Alright, third one. I have integral secant t plus tangent t dt. So I have separated. So integral secant t plus integral tangent t dt. So secant t is same as ln of secant t plus tangent t. And then tangent is negative ln of cosine t plus c. And then I use the log rules. So ln is just to make a quotient with the absolute value. And then I got secant t plus tangent t over cosine t plus c. And then that'll be all. That's okay. But if you go further, instead of the rational expression, you can put secant, you put the secant t. Let me write down nicely. Secant t of secant t plus tangent t and plus c. Okay, all right, let's go to the next page. All right, now example 3. Solve the differential equation. So for the number 3, okay. So in order to do this, okay, so I want to say y equals to f prime of x, because this is f prime of x, right? So 2x over x squared minus 9 dx. Okay. Now I want to say use substitution. So u is x squared minus 9, du is 2x dx. So y equals to integral 2x over u, but dx is now the du over 2x. So 2x cancels out, you got 1 over u du, which is ln u plus c. Now use the given point. So y is ln u is x squared minus 9 plus c. Now y is a 4, x is a 0, and then c is going to be the 4 minus ln 9. Now your differential equation is y equal to the ln of x squared minus 9 and plus 4 minus ln 9. That was a c. All right, now number 4, we are looking for the function from the second derivative and then the first derivative use, okay? So in order to do this, f prime of x is always the integral f double prime of x dx. F double prime of dx is given as negative 4 over x minus 1 squared minus 2 dx. And then if I put it as u equal to x minus 1, so du is dx. Integral negative 4 over u squared minus 2 times dx, du. And then I can integral minus 2 du. And then this is 2 du and minus 2u plus c1. Okay. Oh, okay, we can do that. All right, before, okay, hold on. Let me see if the, I think that I want to go back to the change a little bit, okay? Sorry about that. All right, because over here, what I want to do is I want to control -4. Let's put it for dx, because I don't have to do everything there, dx, right? And then this one is actually integral. So dx is the same as du, but this one we can have a 2x plus c already. So I just need to integral for the first expression. So that's the same as -4 u to the -2 du minus 2x plus c. And then I got integration as a -4 u to the -1 over -1 minus 2x plus c. But I want to call this as a c1 because we're getting a c2. So I got 4 over u minus 2x plus c1. And then given f prime of x is going to be 4 over u, which is u was, okay, I need to go back to the u, was x minus 1 minus 2x plus c1. And then f prime of x was 2, which is 4 over 2 minus 1 minus 2 times 2. c1 is the same as 0, which is 4 minus 4 plus c1. So c1 is equal to 0. So now f prime of x is 4 over x minus 1 minus 2x. Now, in order to find the f of x, now we put the f prime of x and dx. And then you plug it in as f prime of x was 4 over x minus 1 minus 2x and dx. And then same thing as you have the integration. And then I get as 4 ln x minus 1 minus x squared plus c2. And then use f of 2 equal to 3. So 4 ln 2 minus 1 minus 2 squared plus c2 is the same as 3. So 4 ln 1 is 0 minus 4 plus c2. So adding for both sides, so c2 is going to be a 7. So final f of x will be 4 ln of x minus 1 minus x squared plus 7. So that's the final. All right, for the next page. Okay, so now we're going to do the indefinite integral. So for the first one, let's say this is ln of x plus 2 from the -1 to 1. And plug it in, you get ln 1 plus 2, subtract ln -1 plus 2. And then you got ln 3 minus ln 1. It's ln 3 because ln 1 is a 0. Alright, this second one, I want to say u is ln x, which is a du is 1 over x dx. So I want to ignore the limit at the beginning and then I'll put it back later. Okay, so it means this is the same as 1 over x du, and then dx is the same as x du. So x cancels out. We got 1 over du, which is the same as ln u plus c. So ln u is ln x. So now I put it back to the, I'll go back to the x. Now I can use the limit that we have here from e to the e squared. And then I said ln e squared, subtract ln e. Okay, so ln e is squared is the same as ln 2. And then ln e is a 1, and the 1 ln e is going to be 0, so answer is ln 2. Alright, for this one, I used the long division, and then I'm getting 0 to 1 as a limit as 1 minus 2 over x plus 1 dx. And then I get 1 dx back 2, 0, 1, 2, 1 over x plus 1 dx. And then I get the first. The second one, 2 times of ln x plus 1 from 0 to 1. Then when you plug it in, you get the 1 minus 2 ln 2. For the third one, I have you can change to the, oh yeah, this one I'll show you how to change that into the, actually use a u. So to use, let's say, to data, and then which is the u is a 2 data, which means we have to change the power 4, which was a theta, to go to the u, which is plug it in, you got the pi over 4, and then theta pi over 8, and then move the u as a pi over 2. So instead of that, the and then I put the cosine u minus cotangent u du over 2. Now, and you got cosine u minus cotangent u du. And then use the integration, which is going to be the negative ln of cosecant u plus cotangent u, and then minus ln of sine u from the pi over 4 to pi over 2. And then plug it in. So I got half of negative ln, do that as 1 plus 0 minus ln 1 plus ln of 2 plus 1 plus ln of 2 over 2. And then I simplify half of ln 2 plus 1 plus ln 2 over 2, and simplify further, half of ln of 1 plus 2 over 2. Okay, so that's all for the 5.2. Thank you.